Hey everybody, Mr. Judson here. Hope you all had a good weekend. So what we want to look at for today is we want to talk mostly about using our graphing calculator to be able to do things. Okay. Now, having said that, there's something that's really important here. We are not allowed to use cell phones on exams, and many of you have your graphing calculator on your cell phone. We're going to have to get around that. So I'm going to have to set up a day where you guys can come in and check out graphing calculators again. I'm not going to wait for the rest of the school to do it because I'm tired of waiting. So I will be letting you guys know soon exactly when that day is. Make sure you're watching your email for those who don't have one. Okay? So here's the idea. We have a function. Let's just say it's a graph that looks like this. We'll call this f of x. And we want to be able to do three things with this graph on our calculator. First of all, we have to make sure we can draw it and find a complete graph on our graphing calculator. Now, we've already talked about that. A complete graph means you see all the x and the y intercepts. It means you see the high and low spots of your graph. And then we don't really care what goes on from this point out, okay? But what you have to understand is you have to be able to find a window on the graphing calculator that allows you to see this, okay? Now when I say a window means what do you see inside that little box, okay? And we have to remember the x and the y axis go on forever in all directions. When we set a window, sometimes it's possible that our window is set to only see this right here. And we think what we're graphing is a straight line. Well, it's not, because we're not seeing enough of the graph. All right? Or maybe what I see is something like this. I see a little bit more of the graph, but it's still not a complete graph because I don't see all the x and the y intercepts. Okay? What I need to do is I need to have a window that shows me everything, okay? And some people find that to be a challenge. It really means you're just adjusting your x minimum and x maximum values to see as much as you need to see out this direction. And the same thing with your y values, okay? And we'll take a look at that on our graphing calculator. All right. So we already know that these points right here are our x-intercepts, okay? So I'm just going to call this A, B, and C. Our x-intercepts are at A, B, and C. Okay, it's also my zeros, right? If I was asked to find the zeros, I'm finding the exact same points. Really important we get that means the same thing. Here's our y-intercept. I'll just go ahead and label this because there's only one. We also have what's called a relative maximum and a relative minimum. This point right here is a relative maximum, which usually I'm just going to abbreviate this RELMAX. Okay? That's that point right there. And this right here, as you can imagine, is a relative minimum. Now there's one more thing that we're going to look at on this graph, and that is where is this function increasing or decreasing? And so what you think is as you go left to right, just like you read a book, we read a graph the same way. What are my y values doing? Well, they're increasing until I get to a maximum. Then they're decreasing all the way to right here, where I hit a minimum. Then they start to increase again. So what we say is we have three intervals here where things are either increasing or decreasing. Okay? Now, we need to talk about something called interval notation. And interval notation, this is something new to us. It's a way to describe where something is taking place. So I'll just do numbers first and then we'll do it with variables. But let's say I want x values that are between, so remember the between statement. You always use less than signs, the smaller number always goes to the left. From 0 to 10. Okay, so I'm saying my x values can be anything between 0 and 10. You can't go outside of that range. So in interval notation, we would say that that is the interval, this is going to look weird, from 0 to 10. Now the reason I say it looks weird is, to me that looks like an xy coordinate, right? Why do we have two things that look exactly the same but mean something totally different? You know, you could say that means the point 0, 10, or you could say it's the interval from 0 to 10. And you know, how do you know the difference? The way you know is you just have to know what you're talking about. There really is no other way. If I ask you guys to find an interval, then I know this is not an xy coordinate. Or if I ask you to find an xy coordinate, then I know it's not an interval. Okay? Now there's something that's a little bit different here. If I say I've got the interval from 0 to 10, but let's say I put an equal sign there. An equal sign means we're including this number. So now the way I write my interval is going to change a little bit. Now it's the interval from 0 to 10, and I put a bracket there. Okay, so brackets mean we include the number that's out on the endpoint. Here I'm not including 0 and 10, so I use parentheses for that. Here I'm not including 0, so I use a parenthesis, but I am including 10, so I use a bracket on the side where 10 is. If this was an equal sign right here, well then I'd have brackets on both sides. Okay? So in general, what we say is if x is between a and b, and I'll put an equal sign here this time, then this is the interval from a to b, and a gets a bracket because we're including the number on this side, b gets a parenthesis because we're not including it. Here's an interesting thought. If I want x to be, or 0 to be less than or equal to x, which is less than or equal to infinity, which is really kind of a weird thing to say because can x ever equal infinity? I mean, can we ever really get there? The answer is no, we can't. So really, that equal sign shouldn't be there. All right, you'll never have an equal sign with infinity or negative infinity, which means my interval would be from 0 to infinity, and I will never see a bracket here with infinity. Okay? So when we go back and look at this, this part right here is where we are increasing. So let me write this down. My function is increasing. And then here, once we hit that high spot, we start to go down, so we are now decreasing. And a lot of times I just abbreviate this, INCR or DECR. Makes it a little bit easier. Once we hit this low spot, then we begin to increase again. So we are increasing. Everything I just told you here, I guarantee you will show up on the Central Washington test. Every year, they've got a question where we need to go through and find all this stuff that we just wrote down. Okay? So this is a pretty important idea that we're talking about here today. All right. So let's do some practice problems here with our graphing calculator. I know some of the things that I've talked about before, it was really hard to see my calculator because I was at home. So what I'm going to do today is I'm going to use a larger calculator, so it's a little bit easier for you guys to see. So you'll be able to see this whole thing here today, everything that we do. Anytime you guys ever see me do something on the graphing calculator, you should grab your calculator and do it with me. Okay? Don't just sit there and watch me, because I guarantee you, you will not remember this later. You will not remember how to do this. Okay? As I'm going through and finding these zeros, if you're not getting that, you should pause the video right there and get your calculator and work with that until you're like, oh, okay, I got it now. If you need to rewind it, watch me do it again, do that. You know, that's the beauty of the video, all right? But you should always pick up your calculator every single time I pick up mine, okay? Or have it on the screen. All right, so the first thing we want to do is we want to find the zeros for this function. Since this is something we've already done, I'm going to give you guys a chance to do this on your own, and then I'll come back and do it, and you can check and see if you did everything right, okay? So you guys go ahead and try this real quick. All right, so in order to do this, the first thing I want to do is I want to take my calculator and I want to graph this, okay? Now, if you set this equal to 0 and tried to factor, it's not going to factor. Really our goal for today and in the future is to start, you know, to understand that messy numbers can happen, decimal numbers, okay? This one does not have a nice, neat, clean answer to it. So I'm going to graph this. I'll hit my y equals. Let me clear off this old equation. I've got x cubed. Remember, this caret is your exponent button. So x to the third power minus 2x minus 5. I think when you guys hit the caret, when you're putting your exponent in, you have to arrow out of the exponent. So I know when I go back and forth with calculators, that's something that I always forget to do, and I have to go back and fix things. Okay, but there's my function. So I always start with zoom option 4, and there's what it looks like. Now my question is that a complete graph? Do I see all the x and y intercepts? Do I see all the high and low spots? I don't really know exactly what this graph looks like, but I need to explore this, okay? And usually what I do is I do this zoom out feature, option 3. It allows you to come out a little farther and see more, come out a little farther, see more. You can keep on doing that as long as you want to. So I'm going to hit option 3. One of the things that the calculator wants to know is, what do you want to see at the center of your screen? You know, right now you can barely see the cursor flashing at the origin. So I'm going to hit enter because I still want the origin at the center. And so now I see this little kind of up and down thing here. All right? So this is something that we'll talk about later. Whenever you see an exponent, the number of turning points. So when you go up and turn and come back down, it's a turning point. But sometimes a turning point is just like this. It doesn't necessarily come back down. It's just, if I was driving along a road, I'm turning my steering wheel so I don't go off the road, okay? And then I would turn back maybe later. So there should be 2 turning points on this graph, and I can kind of see both of those right here. So now what I want to do is I just want to find a good window that allows me to see the best picture possible. So as far as x values go, really I think if I was between -4 and +4, that's plenty. Okay? For my y values, I probably want to get down to around, I don't know, -6 and up to maybe, I don't know, 2, 3, something like that. So I'm going to set my window now. I'm going to go from -4 to +4 on the x-axis, counting by ones. And then here I'm going to go from, let's see, I thought -6 would work, but I'm not sure. We'll try it and see. -6 to 3. Now, there's no right or wrong here. If somebody said, well, I went -8 to 2, that's okay, as long as you can see all the high and low spots, all the x and y intercepts. Okay? So let's graph this and see what it looks like. All right, so I need to go just a little bit lower here. We're not quite seeing all of it. So I'm going to go back to my window. I'm going to change my y minimum. I'm going to go -8 here. Now I have a good graph. I would say this is a complete graph. Okay? So, you know, at this point I would draw my box acknowledge that this all came from the graphing calculator. As far as what we do here, this is kind of a nice feature. I can just grab this graph and drag it down, and there it is. So I've got a good picture to look at. So I'm just going to go ahead and outline this so we know that this came from a graphing calculator. My window went from -4 to +4 on the x-axis, and from -8 to 3 on the y-axis. Okay? And now I just need to start finding, or I need to find the zeros. Well, there's really only one zero right here. Now, if you look at that, you go, oh, this one's easy. It's at 2, 0. My first question is, are you sure? Are you sure it's not 2.001, 0? We need to know. And so what we're going to do is we're going to go back to our calculator. We're going to say second calc. It doesn't mean calculus, it means calculate. Okay? So anytime I want to find something on my graph, I'm going to use this calculate option. And we're looking for a 0, option 2. And our calculator always has 2 questions, well 3. What are the boundaries? The answer you're looking for is between what and what. We need to give it an interval, okay? And then we need to give it a guess at the end. That's our third question we have to answer. So I can tell it's somewhere close to 2, so I'm going to say for an interval, it's somewhere between 1 and 3. Now somebody else could say, well, I think it's between 0 and 4. And I go, okay, it doesn't matter what the interval is. Just pick one. You just got to make sure you get one number to the left and one number to the right of where we cross the x-axis. So I'm going to go 1, enter, and then 3, enter. Notice how up here we have arrows that point in, that we're looking between those 2 values. It's kind of like saying I'm on the interval 1 to 3. Okay? And now we want to give it a guess. You can either type in a guess, or you can use your arrow keys to get close to where it crosses. I'm just going to look at this and go, it looks like it crosses at 2, and so I'm going to do what's fast, and there it is, 2.09, we got to round up that third digit, 5. So my 0 here is at 2.095, 0. Now, really, I'm giving a coordinate here, and so that means we're talking about an x-intercept. X-intercepts, we have to give the xy coordinate. If I just want to say there's a 0 at x equals 2.095, then that's okay. I don't have to give that as an xy coordinate, right? Because what we're saying is this is the x value that you plug in here and make the whole thing equal 0. Not exactly, because we rounded, but it's close enough. Okay, that's the best we can do. I could not get an exact answer for this. I don't know how. Okay, I really don't. So there it is. We've done what we need to do for this problem. All right, let's try another one. All right, so here's another equation. Again, our highest exponent is 3. That means I could have as many as. Let's back up and just kind of mention something here. Why didn't I get 3 zeros for this? There actually are some other zeros for this function, but they are imaginary, if that makes sense. Remember imaginary numbers? You guys probably talked about in Algebra 3, 4, your square root of -4 is 2i. That's what I mean when I say imaginary. There are some imaginary numbers that you could plug into here and make this equal 0. But in terms of the graph itself, this is the only real number where that happens, okay? So I always want to keep this in mind. Whatever the highest exponent is, there could be up to that many zeros, but it's not a guarantee, okay? All right, so let's go ahead and graph this and see if we can find those zeros. You can go ahead and just use the old graph if you want. I mean, in this case, it's not bad. It's pretty close to what I'm looking for. I just need to go up a little higher and maybe not quite as low. But a lot of times, I'll just go back and do zoom option 4 and start over. Okay. Had I done that, still not quite a complete graph. I still have to go a little bit higher. So I'm going to go to my window. I'm going to say really this is pretty good, but I didn't have to go out as far in the positive direction, so I'm going to go -4 to 3, counting by ones. For my y values, I don't need to go any lower. I'm going to call it -3. The reason I'm punching in neat, clean numbers instead of decimals is because when I label my window, it just makes it easier on me. Okay? I don't need decimal numbers in there. I do need to go a little higher though, so let's go up as high as 6 and see what happens. There we go. That's a pretty good graph. So I now have a complete graph, and I can find the zeros for this. So let me drag this down. It'd be so cool if you guys could just do that on your homework paper. And so this is my calculator window. I went from -4 to 3 here, and from -3 to 6 here. And what I'm looking for is these 3 zeros. What I'm going to do is I'm just going to label these A, B, and C, and I'm going to say that there are zeros at A, B, and C. And I'm just going to go ahead and find those coordinates now. I don't have to write anything else down here. I'm going to write it here, and we know that whatever I put here, that is the coordinates of this point A, because I've labeled both of them. All right, so back to the calculator. I'm going to do second calc, option 2. I'm looking for a zero that's between -3 and -2. So -3 is my left boundary, -2 is my right boundary. If you get those in the wrong order, if you actually say the right side first and then the left side, we're going to get an error message with this. Okay? And the other thing, I make this mistake sometimes. I look at this and I go, okay, that's about 2.5. Well, 2.5 is not between -3 and -2. It's a -2.5. So if you don't choose a number that's inside your boundary as a guess, you'll get an error message for that as well. So -2.5, there it is, -2.414. Comma 0. Now, again, if we stop real quick and look at this, how do I know that that's not an interval from -2.414 to 0? Well, it's not an interval because I'm looking for zeros, and we know those are points, okay? That's what I mean. In the context of what we're talking about, this is how we know what that is. All right, next one for B. So it looks like that's between 0 and 1. So I'm going to do second calc again, option 2. 0 to 1 is my boundaries, and I'm going to give it a guess of 0.5. Looks like the same decimal we had for this, just we don't have a 2 out, or -2 out there. So 0.414, that happens a lot with equations like this or with functions. So 0.414, comma 0. And for the last one, second calc, option 2. This one, it looks like it's right at 1. So I'm going to say it's between 0.5 and 2. But I'm trying to give myself an interval where I'm not including this answer, because I don't want to go find that one again. And my guess is it's somewhere close to 1. It's exactly at 1. Okay. So 1 comma 0. There it is. Now, because we're finding zeros, you could have said here x equals -2.414, x equals 0.414, and x equals 1. But I'll tell you what, if you want to guarantee that you're always getting it right, always answer it as points. Points will never be wrong, okay? But when we say find an x-intercept, if you just say x equals 1, well, an x-intercept is a point on a graph. There you have to list it as a point. So, my thought is, okay, sometimes if you have to list it as a point versus sometimes you don't, Why not just always do it the way you have to in certain cases, okay? And then you always get it right. So the other things that we've talked about here are we have to be able to find relative maximums and minimums, and also where our function is increasing or decreasing. Let me tell you the number one thing that people struggle with on this. When you're talking about where a function is increasing or decreasing, you're not talking about the y values. You are only talking about the x values. Okay? Anytime I say anything about an interval, it's about the x values. Always. Except for one case. If I ask you to find the range of a function, domain and range, remember? Range refers to y values. Aside from that, we never, ever talk about the y values. Okay? That's like one of the biggest mistakes that people make, and I think it comes down to, did you hear somebody say that? You know? That's why we got to focus on these little details. It's so important. So if I want to know where this function is increasing, it's from x equals negative infinity all the way to x equals whatever this is. Where is it decreasing? It's from this x value all the way to this x value. And it's increasing again from this x value all the way out to infinity, because it just keeps on going up forever. Okay? So in order to find the interval where something is increasing or decreasing, you first of all have to know where the maximum and minimum points are. We've got to know where those are at. Okay? So let's go back down to this last one that we just did. And I want to know where is this increasing or decreasing, but first I've got to know what this point right here is. Okay? So let's go ahead and find that using our calculator. Still have the same graph, everything's good. I'm looking for this high point, and I want to calculate something, so second calc. All right, so if I'm looking for a relative maximum, look at option 4 right here. Maximum. So I'm going to do that, and it's going to ask me the same type of questions. What's your left boundary and right boundary? That high point looks like it's between what and what? Well, it's somewhere between -3 and 0. Okay, now could I get a smaller interval? Sure. But our calculator is so fast it doesn't care what interval you choose. We just need an interval. Okay? So left side would be -3. Right side I'm going to say 0. And then again, give it a guess. Where do you think that maximum's at? Oh, it looks like -1.5. So -1.5. I don't ever worry about, am I making a good guess or a bad guess? It doesn't matter. It's going to find it. All you have to do is pick anything between inside your interval. What did I say? From -3 to +3, I could have said 2 or 1. That way I'm hitting one digit instead of 3 buttons to get, or 4 to get -1.5, except at 2, -1. Okay, but it's going to find it. All right, so there's the relative maximum. Here are the coordinates right here. So I'm going to go ahead and write that down. This is the point -1, 387. -1.387, comma, what's my y coordinate? 4.417. That's where my relative maximum is. And remember, I'm going to highlight this in a different color. When I talk about intervals, I'm only interested in the x value. Okay, let's find our relative minimum. So we're back to the calculator. Second calc, this time option 3, that's a minimum. We want to give it an interval. We've got our left boundary and our right boundary. So based on the graph here, if I just said somewhere between 0 and 1, I should be okay. 0 and then 1, hit enter. Now give it a guess. I don't know, 0.8. Okay, 0.721. Comma. And here I have a negative 0.268. And again, the only thing I'm interested in right now is that x value. So if I had to list this over here, I would say my relative maximum is located at this point right here, and I would write it down. Negative 1.387, comma 4.417. And then my relative minimum is going to be 0.721, comma negative 0.268. All right, so what we want to do now is we want to find the intervals where this thing is increasing or decreasing. And so I'm going to write something in here, and this is really important, okay? Put a star here. Intervals where a function is increasing or decreasing are described with x values only. Okay, x values. This is so important because every year I get people who look at this and they go, this function is increasing from negative infinity all the way up to here, and they look at the y value. They're thinking up and down. And we don't describe intervals that way. We describe what's happening in relation to x values as we move left to right. And so intervals always refer to x values unless the question is asking, what's the range? That's the only time we ever talk about y values, okay? So I would try to get that in your head right now, that intervals only refer to x values. And what we're saying is, as we move along the x-axis, where are those y values increasing or decreasing? I don't want to know what the y values are, I just want to know where is that happening in relation to x. Okay? So if I started way out here on the x-axis, let's say I go all the way out to negative infinity, as I'm coming back, my y values are going up, 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 up. They're still going up until I get to about right here. That's where I hit this maximum. So this entire interval on the x-axis has y values that are increasing. And then I've got an interval from here to here where the y values are decreasing. So I got to list these x values. And then from here on out to infinity, my y values are increasing again. Okay? So the way I would write this is this way. Where are we increasing? Well, we're increasing from negative infinity all the way up to this x value. So negative infinity to a negative 1.387. And notice how I'm using parentheses on both ends? I'm using a parenthesis here because you never get all the way to negative infinity, right? If you think you ever got there, there's somebody who can go farther in this direction. And the reason I'm using a parenthesis here is because when we actually get to this point, we're no longer increasing, we have leveled off for a split second, and then we begin to decrease again. So really with intervals where a function is increasing or decreasing, we never see brackets here. We only see parentheses. Okay? We'll never include those maximum and minimum values. All right, then my function starts to decrease from this number right here, negative 1.387, until we get to this x value here, 0.721. And then we start to increase again. So from this number, 0.721, on to infinity, so I'll put this up here, our function is increasing. So, really as you look at these intervals, as long as there's no breaks in the graph, there's no asymptotes, there's no square root where you've got an ending point or something like that, I should see everything from negative infinity all the way to positive infinity. Right? I got all my x values from here to here. And then what fits in between these two is all these x values. And then from here off to infinity. All right. When I look at this, I look at it and I go, everything we've talked about today is on the Central Washington test. This is an important day, okay? We want to make sure that we understand this stuff. All right, so here's what I want for you guys to do. I want for you guys to go back to the first problem that we did. This one right here. We've already found the zeros, there's only one. But I want for you guys to find the relative maximum here. Let's talk about that word relative for a minute. What it means is relative to this area, this is the highest point, okay? I always think of it as hilltops, You've got a mountaintop or a hilltop, whatever you want to call it. There's a high point there. That's your relative maximum. And your relative minimum are like your valleys. Okay, that's a low spot. All the water's going to run down and it's where the river's at. Right? Are there higher points here than here? Sure there are. Yeah. But relative to this area, this is the highest point. Relative to this area, that's the lowest point. Okay? So let's find our relative maximum and minimum. And then I want for you guys to list the intervals where this function is increasing or decreasing. Okay, you guys go ahead and try it. All right, so I've got my graph here. I still have the same window. I don't have to redo that. But what I'm looking for is I want to be able to find this relative maximum and this relative minimum. And so I'm going to go second calc. Find a maximum, I want option 4. And it looks like it's somewhere close to -1, so for an interval I'm going to say it's between -2 and 0. So -2 is my left boundary, 0 will be my right boundary. And my guess, -1. Even though I know it's not the right answer, it's going to be close to that. Alright, so a -0.816. And then my y-coordinate was -3.911. There's my relative maximum. And then for my relative minimum, second calc, this time I want option 3. This is close to +1, so I'm going to say an interval from 0 to 2. And 1 is my guess. And here I got 0.816. Remember how I said sometimes these numbers just repeat themselves? Don't know why that happens. So 0.816, comma, -6.089. So again, when I list my intervals for where it's decreasing or increasing, these x values are the ones that I want to use. All right, so it's going to look similar to the other problem because it's a similar type of curve, but just with different numbers. So where is this function, so where is this function increasing? From -infinity, because see it's going up here, so from -infinity all the way up to this x value, which is a -0.816. So -infinity to a -0.816. And it's also increasing from this x value on to infinity. So think on the x-axis from here all the way out to infinity, it's also increasing. So positive 0.816 to infinity. And where is it decreasing? in between those two intervals, from negative 0.816 to a positive 0.816. There we go. Oops, I should say right here, this is a relative minimum. All right, so we kind of summarize what we've done here. We found our complete graph, we drew a picture of it, we've labeled our x-axis and our y-axis. Got to do that. We drew a picture of what it looks like. We've labeled our relative maximum and our relative minimum, and we have also found our intervals where this is increasing and decreasing. And we found our zeros where those occur. These are all things that we're going to get asked to do today with our graphing calculator, okay? This is primarily a graphing calculator assignment. All right, so the other thing that we're going to get asked to do today is they're going to ask us to find the average rate of change for this function between my first x value of 1 and my second x value of 5. Really, this is kind of like saying on the interval 1 to 5. Okay, find the average rate of change of this function on this interval. This sounds like kind of a rough question, but it's really not. This will be the easiest thing we do today, right? Average rate of change, what we have to remember about this is it's just a slope. All they're asking us to do is find the slope. Find the average slope of this function on this interval. And it really means if I plug in a 1 to get an xy coordinate and then a 5, I'm really just finding the slope between those 2 points. So I would say here that f of 1 is equal to, if I put a 1 in here, I get 1 squared, that's 1, minus 2, so 1 minus 2, that's a negative 1, plus 8, that's 7. By the way, this is showing your work, right? I'm not doing the entire problem and just writing down an answer. But plugging in a 1, the only thing that's missing is some arithmetic. I don't need to see that. I look at this and I see, oh, okay, yeah, you plugged in a 1 and you got a 7. Good. You're moving in the right direction. Now, if you had f of 1 equals 5, well, then I realize you made a mistake there, so you're struggling with the arithmetic. Maybe we ought to write that down. Okay, but I don't need to see it. So this is the point 1 comma 7. I plugged in a 1, I got a y value back. F of 5, if I plug that in, I get 25 minus 10. Easy enough, I can do that in my head, that's 15. Plus 8, that's going to be 23. So I got the point 5 comma 23. So find the average rate of change, which means slope. I really just want to find the slope between those 2 points. And I usually abbreviate this A-R-O-C. Sometimes people call it AROC. Average rate of change is just a slope, y2 minus y1. So 23 minus 7 over x2 minus x1. Subtract that, you get 16 over 4. There's my average rate of change. Okay? All we're talking about when we say this is slope. And this will come up next year as well in calculus. We'll have to find average rates of change. It doesn't change. It's still just a slope, right? What it means is, if I was to graph this function, which it looks like a parabola, let me just draw a picture here real quick. Here's my parabola. I don't know where these points are, but let's just say here's one point and here's another one. If I was to do little segments and find slopes, because a slope really refers to a straight line, right? Not a curve. Next year I'm going to tell you I'm lying when I said that, okay? In calculus it does refer to a curve. But based on what we know right now, slopes only refer to straight lines, okay? So if I took a whole bunch of little segments where the 2 points are really close together, and I find the slope of all those segments, now I drew about what? 2, 4, 6, about 8 segments in there. Really I would want to draw more than that to get an accurate answer. I'd probably want to draw 100 of them. But if I did that and I averaged all those slopes, this is the average that I would get, okay? Whatever the slope is between these 2 points, that slope is the average of all these little segments added up and divided by however many we have. Okay, that's what we're finding. We don't need to do this. We're just going to go with the easy route. Find 2 points, and then get the slope between those, and there's your average rate of change. All right. Let me give you guys one to try. All right, so you guys go ahead and try this on your own. We want to find the average rate of change, find the slope for this function from this x value to this x value. So if I would have said on the interval from 2.5 to 5, same thing. All right, you guys go ahead and try it. All right, so what I need to do is I need to plug these numbers in. 2.5, if I plug this in, I'm going to get 2 times 2.5 is 5, minus 1 is 4, so I get the square root of 4. Well, that's kind of nice, at least it's something easy to work with, which is 2. That gives me the point 2.5, comma 2. And if I plug in a 5, I get the square root of 10 minus 1. That would be the square root of 9, which is 3. So again, not too bad. 5 comma 3. And so now find the slope for the average rate of change. So the average rate of change is equal to y2 minus y1 over x2 minus x1. And so that's going to equal 1 over 2.5. Now, you can grab a calculator and divide this and see what you get. I'm one of those people that I feel like the only way we stay sharp with simple math skills is you got to do it, right? So I try and do as much as possible without a calculator. I don't want to grab a calculator unless I really have to. So I'm thinking of this as 1 divided by, if I want to change this to a fraction, it's 2.5. And 2 1/2 would be 5/2. And now to divide by a fraction, I would flip it over and multiply. So that would equal 1 times 2/5, which would just be 2/5. Now if I divided this, I would get 0.4 for an answer. Okay? But I didn't have to touch a calculator. I don't care if you say 2/5 or 0.4, they're both the same, right? If I ever try and tell you that they're not the same, you guys should laugh me right out of here. All right? Of course they're the same. We spent a lot of time in younger years of school talking about converting decimals and fractions back and forth. This is exactly equal to 0.4. Right? Doesn't matter to me which one you guys say. But I like the fact that I was able to do that without picking up a calculator. I didn't look at this and think 0.4 was the answer. Okay, that wasn't popping into my head. But the rest of this did, and it was fairly easy to do. All right, let me get you guys a homework assignment. All right, so here's our homework assignment, assignment number 5. We're starting our 5th week here. It's on page 63, and we're doing 39 to 67 odd. You're going to need a graphing calculator for this. So if there are people who still don't have a graphing calculator, you need to let me know, and you need to get here ASAP to get one. When I say ASAP, I mean today or tomorrow. All right? And what I will do is let me put it this way. All you have to do is come to Wilson. Now I can't do this during class time, okay? So it has to be outside of class time. If you come here at 2 o'clock, that's when 3rd period ends, all you have to do is call my phone in my classroom here, Here's my number, 253-571-6052. Just call that number, tell me who you are, can you bring me a calculator, and I will come down and check out a calculator to you, okay? But you gotta have one, okay? I think you want that in your hand. Even if it's better than what's on the computer, it's better than what's on your phone, but we need to have that in our hand to be able to do this. All right, also don't forget, starting this week, we're now going to 3 videos per week. I told my calculus class today, I said, you know, anybody that's sitting there going, you know, you've got the wrong mindset. What you guys should all be thinking right now is, we're in a situation where we're not learning as much as we're supposed to learn, and that's going to affect us in the future. There's no way it doesn't. There's no way it doesn't affect us, okay? Eventually when things get back to normal, how well am I going to be able to function in a math classroom, in a science classroom? Do I know the things I'm supposed to know from previous years? It's going to make a difference. You guys on your end should be sitting there going, I want 3 videos. I don't want to be dragging behind. I don't want to be this age group that is always a little bit off because of this virus thing, right? You guys should be sitting there going, I'd kind of like to get to 4 videos a week so that I make sure I learn as much as I'm supposed to, so I'm prepared for the next level, whether it's college or the next year of math, which is calculus. I just think that's really important, okay? So we will have videos. If you're in 3rd period, it'll be Monday, Wednesday, Thursday. If you're in 4th or 6th period, you're going to get your videos on Tuesday, Wednesday, Friday. All of this stuff, 3 days worth of work now, is now due on the following Wednesday. Okay, it's no longer just 2 days worth of work. Starting this week, it becomes 3 days of work that we're turning in next week. All right, you guys, that's all I have for you today. Take care, stay safe. We'll talk to you later.